Hi students, exercise number 1.1, question number 7. Let's see, let A is equal to the set of all natural numbers less than 8 is given, and then set B the set of all prime number less than 8, and then set C is the set of all even prime numbers. Verify that here we have two Roman numbers. First is the first Roman number A intersection B cross C is equal to A cross C intersection of B cross C. First we want to find out what is the set of A, B, C. Solution. The set A is equal to, see the set of all natural number. Natural number means start from 1, right? And then less than 8 means we get the number that is 1, 2, 3, 4, 5, 6, 7. Less than 8. These are the numbers. Natural number less than 8, and then set B the set of all prime number less than 8. We know the prime numbers, right? The prime numbers less than 8 is 2, 3, 5, 7. These are the prime numbers less than number 8. And then the set C is given as the even prime number. We know only one is the even, only one number, that is 2 is the even prime number. Now we have find out what is the set A, B, C. Now we go to the Roman number 1. In LHS set, we have to find out A intersection B cross C. That is A intersection B cross C. First, we want to find out what is inside the bracket. That is inside the bracket we have A intersection B. Right? The set of A intersection B is equal to, the set A is equal to 1 to 7. Right? Intersection of the set B is 2, 3, 5, 7. First we want to find out the intersection portion of A and B. See, intersection means we know that we want to find out the common term between the two sets. Here 2, right, 3, 5, 7. 2, 3, 5, 7 is the common between the two sets. So the element is 2, 3, 5, 7. This is A intersection B. Now we want to find out A intersection B cross C. A intersection B cross product of C. Now A intersection B is 2, 3, 5, 7, and then the set C is we have only 2. 2, 3, 5, 7. Cross product of set C is number 2. Now by the cross product bit, each and every element is mapping with the second set element, right? In second set we have only number 2, so 2 is mapping with 2 and 3 is also mapping with 2, right? We write the ordered pair here. This term is equal to, the ordered pairs are 2, 2 and then 3, 2, 5, 2 and then 7, 2. These are the ordered pair of A intersection B cross C. So this is the LHS set. Let me take it as equation number 1. Now we want to find out what is the RHS set. In RHS set, A cross C intersection of B cross C, right? First we want to find out the inside the bracket. First we want to find out what is A cross C, and then we want to find out B cross C. Then we have to find the common between the two sets, that is the intersection portion. So A cross C is equal to, the set of A is 1 to 7 and set C is 2. Cross 2. Right? For here we have the ordered pair, that is 1, 2 and then 2, 2. So each and every element in the first set is mapping with second set, right? In second set we have only number 2 only, so each and every term is paired with that 2. So 2 is 2, 2 and then 3, 2 and then 4, 2, 5, 2 and then 6, 2 and then 7, 2. This is the A cross C. Now we want to find out what is B cross C. The set B cross C is equal to, the set of B is here 2, 3, 5, 7, right? Cross product of set of C is number 2. Now we want to find the ordered pair for this Cartesian product form, right? 2 comma 2, 2 is mapping with 2, and then 3 comma 2, and then 5 comma 2, and then 7 comma 2. This is the B cross C. Now we want to find out the A cross C intersection portion of B cross C, right? Here A cross C intersection of B cross C is equal to. Now compare the first and second set. A cross C is the first set, B cross C is the second set. Now we want to find only the common ordered pair in between the two sets. See, 1 comma 2 is not here, and then 2 comma 2 appear in both the set, and then 3 comma 2, and then 4 comma 2 is not there, and then 5 comma 2, and then 7 comma 2. So only 4 ordered pairs are the common terms. So we write that 4 ordered pair, that is 2 comma 2, and then 3 comma 2, and then 5 comma 2, and then 7 comma 2 is the ordered pair of RHS. I take the equation number 2. Now compare the first and second equation. See, here it is the first equation, that is 2 comma 2, 3 comma 2, 5 comma 2, and 7 comma 2 is the ordered pair. Now compare the second equation, 2 comma 2, 3 comma 2, 5 comma 2, and 7 comma 2 is the. So from first and second equation, from 1 and 2, we concluded that LHS set is equal to RHS set, right? So A intersection B cross C is equal to A cross C intersection of B cross C. Hence, prove the result. Hi students, exercise number 1.1, question number 7, Roman number 2, right? Roman number 2, we want to find out A cross of B minus C is equal to A cross B minus of A cross C. We have already found out what is the set A, B, C. The set A is number 1 to 7, that is less than 8, natural number, right? Set B is the prime number less than 8, so 2, 3, 5, 7. Set C is the even prime number, so set C is the number 2. Now we want to find out the LHS set. See, LHS set is A cross of B minus C. First we want to find out what is inside the bracket, right? That is inside the bracket we have that B minus C is the term. So B minus C is the set. The set B is equal to 2, 3, 5, 7 minus of set C. We know how to subtract that, right? First select the first set. The first set elements, any elements is appeared in the second set bin. Just cross out. We want to look only the first set element only. Even though there is more element in the sets, second set means you should not be calculate that set. So 2 will be cancelled. So the remaining elements only we consider the first set. What are the elements remaining in the first set only? We have right either in second set we have 1 or 3 number will be there. We should not be count that, right? So B minus C is equal to 3, 5, 7 is the number. Now we want to find out A cross of B minus C. That is A cross of B minus C. The set of A is 1 to 7, right? 1, 2, 3, 4, 5, 6, 7. Cross product of. Now we have find out that is B minus C is 3, 5, 7. Now we want to find out the ordered pair. Cross means we have to find the Cartesian product form. Now we have to write the ordered pairs. To write the ordered pair, I drawing a diagram. It is very easy to find out the ordered pair of the sets. This is set A. This is B minus C. The set A contains 1 to 7. Set B minus C is 3, 5, 7. We know that how to write the Cartesian product form. In first set, first element is mapping with each and every element of the second set, and then second elements also we have to mapping each and every element of the second set. Like that, how many elements is there? We have to mapping that each and every element of the second set. So the first one is mapping with 1 to 3 and 1 to 5 and 1 to 7. Then we have to write the ordered pair. See, 1 comma 3 is the first ordered pair, and then 1 comma 5, 1 comma 7. Next we select the second number, second element in the first set, 2, 2, 3, 2, 5 and 2, 7. And then 2, 7. And then the third set is 3, 3, 3, 5 and then 3, 7. And then fourth one, 4, 3, 4, 5 and then 4, 7. And then 5 is mapping with 3 and then 5 is mapping with 5 and then 5 is mapping with 7. And then number 6 is mapping with 3 and then 6 is mapping with 5 and then 6 is mapping with number 7. Right? And then last number 7, it should be mapping with each and every element of the second set. Then the ordered pairs are 7, 3, 7, 5 and then 7, 7. This is the A cross of B minus C. Let me take it as LHS side is equation number 1. Now we want to find out what is the RHS side. The RHS side we have A cross B minus of A cross C. A cross B minus of A cross C. Right? First we want to find out what is the A cross B and then we have to find out A cross C. Then we have to subtract the two sets. Here A cross B is equal to the set of A is 1 to 7. Cross product of set B contain 2, 3, 5, 7. Now we want to find the ordered pair for this. So that is 1 is mapping with 2 and 2 is mapping with 3 and each and every element should be mapping with. Here I draw that. Let's see that 2 set will be here. This is A set, this is B set. The set A contains the number 1, 2, 3, 4, 5, 6, 7 and set B contains 2, 3, 5, 7. 2, 3, 5, 7. We know that how to write ordered pair. The first element is mapping with each and every element of the second set element and then one by one we have written. Here A plus B is equal to, then the ordered pairs are, see that 1 is mapping with 2, 1 is mapping with 3 and 1 is mapping with 5 and 7, right? Then the ordered pairs are 1, 2, 1, 3, 1, 5 and then 1, 7. And then the remaining elements also mapping with the second set element. Then 2 is mapping with 2 is mapping with 3, 2 is mapping with 5 and then 2 is mapping with 7. And number 3, that is the third element in the first set, is 3. 3 is mapping with 2, 3 is mapping with 3 and then 3, 5 and then 3, 7. And then fourth element is number 4. 4 is mapping with each and every element, that is 4, 2, 4, 3, 4, 5, 4, 7. And then fifth element is 5, 5, 2, 5, 3, 5, 5 and then 5, 7. And then here we have 6 and 7. So we have right hand to also 6, 2, 6, 3, 6, 5 and then 6, 7. The last one is 7, 7, 2, 7, 3, 7, 5, 7, 7. So this is the cross product of A cross B. Now we want to find out A cross C. Here we have to find out that A cross C. Then we have to subtract the two sets. Here A cross C is equal to, the set A is 1, 2, 3, 4, 5, 6, 7. Set C we have only number 2. So 1 is mapping with 2. This is set A. This is set C. 1 is mapping with 2. 2 is mapping with 2. Right? Then the ordered pairs are 1, 2, 2, 2, 3, 2 and then 4, 2, 5, 2 and then 6, 2 and 7, 2. This is A cross C. In C we have only one element, so we get that ordered pair like this, right? Then we have to find out the RHS set is A cross B minus of A cross C. Now we have to subtract the first set and second set. See, the first set is A cross B, the second set is A cross C. Here see 1, 2 appear in the both the set, so we have to cancel this, and then 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2. So these all are cancelled. So the remaining set of ordered pair only you have to write here. Then the ordered pairs are 1, 3, 1, 5, 1, 7, and then 2, 3, 2, 5, 2, 7, 3, 3, 3, 5, 3, 7, and then 4, 3, 4, 5, and then 4, 7, 5, 3, 5, 5, 7 here, and then 6, 3, 6, 5, and then 6, 7, and then last pair is 7, 3, 7, 5, 7, 7. So this is the RHS side. Let me take this equation number 2. Now see the first and second equation. Compare the first and the second equation. Calculate that 1, 3, 1, 5, 1, 7. All elements are appeared here. And then 2, 3, 2, 5, 2, 7. Right? And then 3, 3, 3, 5, 3, 7. And then 4, 3, 4, 5, and 4, 7. So let that equals 1 and 2. Both the ordered pairs are equivalent from 1 and 2. The LHS equal to RHS. The LHS side is A cross of B minus C is equal to the RHS side is A cross B minus of A cross C. Hence the proof. Hi students, exercise number 1.2. Question number 1. Let A is the set given as 1, 2, 3, 7 and B is the set is given as 3, 0, minus 1 and then 7. Now our question is, which of the following are relation from A to B? We know that clearly the relation is here subset of a Cartesian product. Relation is here subset of a Cartesian product. Let's see the solution. By the relation condition means the relation R is equal to A comma B such that the first element A is belongs to the A and then the second element B is belongs to B. This is the relation, right? Now we see that Roman number 1. The Roman number 1 is given as R1 is equal to, the elements are 2, 1 and then 7, 1. Now compare this with the set A and the B. This is the set A, this is set B. Set A contains 1, 2, 3, 7. Set B contains 3, 0, minus 1, 7. Now we have to find the Cartesian product means one is mapping with each and every elements of the second set, right? And then 2 is also mapping with each and every elements of the second set element like this. Now we compare this. 2 is belongs to A, right? First element is belongs to A and then second element is belongs to B elements. Here 7 in this here 7 is the first element belongs to A and then 1 is belongs to B. Now come to the set A and B. Is there 2 in the set A? Yes, so it belongs to A. And 7 is also belongs to A. So 2 and A are belongs to the set A. But C, in 1 is not belongs to B. The element 1 is not in the set B. So it is not belongs to. So there is no element 1 means, so there is no relation. So it is not a relation. It is not relation to relation from A to B. It is not relation from A to B. Now we see the second Roman number. The second Roman number is given as R2. R2 is equal to, the set is minus 1 comma 1 is the set. See, the first element is belongs to set A and second element is belongs to set B. Here I write first element is belongs to set A and then in second element is belongs to set B. Now come to the set A. There is no minus 1 in the set A. So minus 1 is not belongs to A and also 1 is not there in set B. Right? This is also not belongs to B. Therefore, it is not a relation from A to B. Next, third problem number 3 is given as R3. The relation is R3. The ordered pairs are 2 comma minus 1, 7 comma 7 and then 1 comma 3. These are the three ordered pairs. Here also the same condition. The first element belongs to set A. Second element belongs to set B. See here 2, 7, 1. 2 is belongs to set A. 7 is belongs to set A. And then 1 is belongs to set A. Now come to that set A. Here 1 is there and then 2 and 7. So it belongs. Now come to the second one. Minus 1 is belongs to B. And then 7 is belongs to B. Here 3 is belongs to set B. The second element, right? Now see, minus 1 is here and then 7 is also up here and then last number 3 is also up here. So it is a subset of the Cartesian product A plus B. So it is relation from A to B. Right? Let's see the fourth Roman number is given as 7 comma 1. R4 is given as 7 comma minus 1 and then 0 comma 3 and then 3 comma 3 and then 0 comma 3. Now the first element is belong to the first set, right? So 7 belongs to A, here 0 belongs to A, 3 belongs to A. Here already you have written the 0, right? Now second set, minus 1 belongs to B, 3 belongs to B and 7 belongs to B. Now come to the set. Here 7 is up here and then 0 is not in the set A. So 0 is not belongs to A. 0 is not belongs to A. So we say it is a not a relation. Even only one ordered pair is not in the subset of A plus B means it is not a relation. Relation from A to B. Exercise number 1.2, question number 2. Let A is the set 1, 2, 3 up to 45 is given and R be the relation defined as the squares of on A. R is the relation, the squares of on A and then write R as the subset of A cross A. Subset of A cross A. Also find the domain and the range of R. Here the relation means let me take as R as the relation. The relation here, the first set is X, that is A. The first set I get as X and then the relation of the codomain is squares of on A. Squares of on A means here X square is the second element. First element is X, let me take it as first element as X and then second element is squares of the element and then such that here X belongs to A and then X square is also belongs to A because here A plus A is the relation. So the relation is conditioned like this. Now the A has the element of 1 up to 45. If it is square means we get only 1 square and then 2 square is 4 and then 3 square. Let me write that the squares of the element, squares of A is, that is 1 square, 2 square, 3 square, 4 square, 5 square, 6 square and then 7 square is 49, right? But here we have only up to 45 only the number. So 7 square is not possible. Here we have up to 6 square is the number. This term can be written as 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, and then 25, and then 36. Now, we have to write the ordered pair of this A and A square, right? Now, A cross A is the ordered pair, then the ordered pairs are R is equal to, then the ordered pairs of R is equal to, the first element 1 is mapping with 1, right? And then second element 2 is mapping with 4, and then 3 is mapping with 9, 4 is mapping with 16, and then 5 is mapping with 25, 6 is mapping with 36. Because in relation we have already said that the x is 1 means that the squares of x is 1 square. The x is 2 means that the squares of the 2 is 4. So this is the A cross A subset of A cross A. Now here domain is equal to, domain means you know that the domain is always the first set element is the domain, right? First set element is the domain. Here 1, 2, 3, 4, 5 and then 6. 1, 2, 3, 4, 5, 6 is the domain of the set, right? And then range of R is equal to, range of R is equal to where the element is mapping. This is the set A, this is the x square values, that is 1, 4, 9, 16, 25 and then 36. Here where the 1 is mapping with 1 and then 2 is mapping with 4, 3 is mapping with 9 and then 4 is mapping with 16, 5 is mapping with 25 and then 6 is mapping with 36. Where the first set element is mapping with the second set, that mapping element is called a range. The codomain is different from the range. Only the mapping elements are called the range. So the range R is 1, 4, 9, 16, 25, 9, 16, 25 and 36. So this is the, they are asking the find the domain and the range of R. So this is the domain and the range of R.